Hello, this is Mr. Huber. In this lesson, we're going to look at two variable inequalities, linear ones. First, we want to talk about what it means to be a solution. To be a solution for an equation or inequality, it means the values that you could plug in for whatever variable or variables are present and make the statement true, make the equation or inequality a true statement. So let's look here at what it means to be a solution for an inequality in two variables. So we're going to have the inequality x minus 3y is less than or equal to 6. And what we're going to do is we're going to determine if these ordered pairs are solutions. So let's start with 10 comma 2. To figure out if 10 comma 2 is a solution, we plug in a 10 for x and a 2 for y and see if it makes a true statement. So we have 10 minus 6 is less than or equal to 6, which is 4 is less than or equal to 6. That is a true statement. 4 is less than or equal to 6. So this would be a solution for that inequality. The next ordered pair is negative 2 comma 3. So if we plug those values in, we're going to plug in a negative 2 for x minus 3 times 3 less than or equal to 6. And that's going to be negative 2 minus 6 less than or equal to 6. Negative 8 is less than or equal to 6. Also true. Negative 2 comma 3 is a solution for that inequality. And then the last point, 6 comma negative 1. And we're going to plug those values in, and we're going to get 6 minus 3 times negative 1 is less than or equal to 6. That'd be 6 plus 3 is less than or equal to 6. 9 is not less than or equal to 6. This would not be a solution for that inequality. So there can be multiple points, ordered pairs, that are solutions for the inequality. What does that really mean, and what does it look like? Okay, well, let's check that out. The graphs of linear inequalities in two variables are all the ordered pairs that are solutions of the inequality, and it's going to look something like what you see on your screen here. You're going to have a line drawn, and then we're going to do some shading. The part that's shaded is the solutions. So all of these points here would be solutions for whatever inequality we're dealing with in this particular problem. We don't have an actual inequality, but if we did, all the points on this line, because it's a solid line, would be solutions, and then all of these points where it's shaded would also be solutions. So how can we figure this out without testing every point? Are we going to just keep plugging in x's and y's forever? Well, we don't want to do that. We're going to figure out how to graph that boundary line and then know which side of it to shade. So let's look at that. To graph the linear inequality, we want to graph the boundary line. So graph it like it's an equal sign, like it's a y equals mx plus b. And when we graph the line, we're going to use a solid line if it's a less than or equal to or greater than or equal to. So if it's got the equal to part, we graph a solid line because it means we're including the line as part of the solution. We use a dashed line if there's no equal to. This is like our open circle. When we graph on a number line, we put an open circle. This is like our closed dot, solid, closed-in dot, like a solid line. And then we're going to pick a point to test. Pick a point that's not on the boundary line and see if it's a solution. If it is a solution, we shade everything that's on that side of the line. If it's not a solution, we go to the other side and we shade everything on the opposite side of the line from that point that we tested. So you can pick any point you want to test. We're going to talk about ways to, pick points that will be relatively easy to test. Okay, so graph the boundary line, test a point, and shade. Okay. Let's check it out here with this example. Okay. If we want to graph this inequality, again, the first thing we're going to do is graph it like this is an equal sign. We're going to graph it like it's y equals 4x minus 3. So we could graph our y-intercept at negative 3. And then we can use our slope. We're going to go up 4 and over 1. And put a point there. And again, we could go up 4 more and over 1, and we could keep doing that. We could go down 4 and to the left 1. Right? And we'll have these points that are going to make the boundary line. And because it's just a greater than without the equal to down here, that means we're going to have a dashed line. So a dashed line, we're going to draw a line through those points that looks like this. That's an indication that the line itself, if I pick a point on the line, it's not going to be a solution. Just points on one side of the line or the other. So now how do we know which point to pick? Well, we could pick anything we want. Picking like -7, -2 will work, but it might not be the easiest to plug in. Pick things with zeros and ones. Those are usually pretty easy to plug in. We could try 0, 0 itself. It doesn't look like our line goes through the point 0, 0. If you were a little unsure, maybe you do 0, 2, which would still be pretty easy to plug in. Okay, so pick something that's relatively easy to plug in and put it in for the x and the y. Let's try 0, 2. All right, so we're going to test the point right here, 0, 2. Okay, so we're going to test 0, 2. That means I'm going to put a 2 in for y greater than 4 times 0 minus 3. So that's 2 is greater than 0 minus 3 is -3. That's a true statement. So that means we want to shade the side of the line that contains that point we tested. So we want to shade where this point is and everything that's on this side of the line. Okay? And so we can do that. Do some shading there and go right up kind of to the line, but don't cross it. Okay? That would be our solution. Any point that's in this shaded portion of the graph, if we plug it in for the x and the y and that inequality, is going to make the inequality true. So I could pick any of these points over here, and I know they're going to work. Okay? Let's try a different colored arrow there. Any of the points over here will work. I could pick any point there and keep going. I could keep going up this way forever. This shading would extend well off the grid we have there. Those are all of the solutions for that inequality. Let's try to make a little stop here before we head off on another example. Peach pit stop. Who is the only baseball player in American League history to hit 400 for a season 3 different seasons? Hitting 400 in a season is pretty tough. So we start to reveal here. See, it's a former Detroit Tiger. The Peach pit stop is a clue. He was known as the Georgia Peach, and he hit over 400 in those 3 different seasons. His name is Ty Cobb. Ty Cobb, the Georgia Peach. He wasn't much of a peach from stories told from back in his day. He was a pretty ornery and nasty player, but heck of a ball player as well, holding that record for hitting 400 3 different seasons. Okay, let's look at another graph of an inequality here. We want to graph x plus 2y is less than or equal to 8. This is going to require a little work to get the y by itself. Right? We want to get that y by itself. So we could take this equation, I'll write it over to here, and subtract x on both sides as a first step. I'm going to have 2y is less than or equal to -x plus 8. And then I want to divide both sides by 2. And I'm going to have y is less than or equal to -1 over 2x plus 4. Right? So there's a -1 in front of here, in front of the x, -1 over 2, -1 over 2x, and then 8 over 2 would give me the 4. Okay? So now I've got this inequality I can graph by first graphing the boundary line. So I'm going to graph a point at 4. That's my y-intercept. And then I'm going to use -1 over 2. So I'm going to go down 1 and over 2. Down 1 and over 2. Again, I could keep going down 1 and over 2. As long as I've got a few points I can use to graph. I could go up 1 and left 2, right, and see that I'm having that same line. And it's going to be a solid line because I have the equals to, less than or equal to. So that's like our filled in circle on the number line on this graph. That's going to be a solid line. So that means I could take my line and I could draw it through those points. And that's my boundary line. Again, if you pick any of the points that are actually on that line, they will be solutions. So for instance, if you plugged in 4, 2 up here, let's try that out. Let's plug in the point 4, 2. Okay, so if I do that, I'm going to check 4, 2. I put a 4 in for x plus 2 times 2 less than or equal to 8. I'm going to get 8 is less than or equal to 8. That works. Again, that's why we have a solid line. If it was just the less than, right, if we went over here and we took away this equal to part and we had just less than 8, we'd have 8 is less than 8, which would not be true. And that's why this would be a dashed line then. But we're including the line, so we want a solid line because all the points that are on the line also will make this inequality, true. Okay? Now, let's pick a point that's not on the line and test it. This case, testing 0, 0 seems like a pretty good idea. So if we test 0, 0, right, we can do that by plugging a 0 in for x, plus 2 times 0, less than or equal to 8. That's 0 plus 0 is less than or equal to 8. That's true. So that means we want to include and shade everything on that side of the boundary line. So again, we're going to shade all over here and indicate that all of those points in that shaded portion of the graph are solutions, and so is the actual line itself, any points on the line. Okay, so again, graph the boundary line, test a point, and you'll know which side to shade. All right, let's do one more example here. Again, a little work to get this solved for y and a couple other things that will come up here that we want to make sure we're aware of. So the first thing would be we could subtract 4x on both sides. Okay, so when I do that, I'm going to get negative 3y less than or equal to negative 4x plus 9, right? I can subtract 4x on both sides to get it to cancel out. Don't forget there's this negative sign in front of the 3y, right? Carry that over. And now I'm going to need to divide by negative 3. So if I divide by negative 3 on both sides, I'm going to get y less than or equal to 4 over 3x minus 3. Only we made a mistake here, okay? Or I should say I did. I guess I shouldn't assume you did. But if we bring this down, we divided on both sides of an inequality by a negative. That means we need to switch this inequality. The rest is accurate. Negative 4 over negative 3 is a positive 4/3. 9 over negative 3 is a negative 3. But since we divided on both sides of an inequality by a negative, we need to switch this inequality. So let's turn that around, and let's make that a greater than or equal to. Okay. Now, we could graph this boundary line and then test a point to shade. So I'm going to go to negative 3 on my y-axis. Then I'm going to go up 4 and over 3. Then I'm going to go up 4 more and over 3. And I could go from my y-intercept to negative 3. I could go down 4 and left 3, right? Negative 4 over negative 3 would be down 4, left 3. That still gives me the same positive slope. If I do that, we'll see how that works out. I'm going to go down 4 and left 3. And I have that point. And I'm going to have a solid line through those points. And then I have to figure out a point to test and to shade it. Okay? So we could check a point, let's say 0, 0, because that's relatively easy to plug in. And we're going to end up with 4 times 0. Let's make that parentheses then 0. 4 times 0 minus 3 times 0 is less than or equal to 9. So I'm going to get 0 is less than or equal to 9. That's true. Since this point worked here at 0, 0, so will everything on that side of the line. And I can shade it, and that would be my graph. So you're getting the hang of it here. Hopefully you're seeing how we can go about getting a line to graph for the boundary. We need to get the y by itself to have a y less than or greater than or less than or greater than or equal to. So we know whether it's a solid line when we include the equal to. It's a dashed line if this equal to wasn't there, if it was just a greater or just a less than symbol. We get the boundary line, graph it like a y equals mx plus b, and then test a point so we know where to shade the graph.